All right, so for our last day of Module 6, we're going to finish up our talk about volume, and we're going to talk about three more shapes, a cylinder, a cone, and a sphere. Now, we already learned a cylinder earlier this year. We said a cylinder is like a prism, but with a circle for its bases instead of a polygon, instead of a square or a triangle or any other polygon. I said it's basically a can shape, like a soup can or a soda can or something like that. That's a cylinder. So here's our picture. There's only two aspects to it. We have the height, which tells how tall that can is, and then we have the radius of the base. The circle on top has a radius. So with just those two numbers, height and radius, we can do volume of a cylinder. So volume of a cylinder is just like volume of a prism. Area of the base times height. Volume equals capital BH. But we know the base this time. See, on a prism, we don't know what the base is going to be. We have to do one thing if it's a square, and one thing if it's a triangle, and one thing for a different shape. But for a cylinder, the base is always a circle, so its area is always pi r squared. So what we can do is we can just turn that into a formula. And we did this already. This is more of a review. We did this earlier in the year. But if I think of this as capital B times H, capital B, the area of the base, is pi r squared. Now, since it's always pi r squared, it never changes, I said, let's not call it capital B times H for a cylinder. Let's just call it pi r squared H. So now all of a sudden we have a formula. You can think of it as capital B times H, because that's what it is, if that's easier for you to remember. Or you can just remember volume of a cylinder is pi r squared H. And that's going to set us for our first example, find the volume of the cylinder. So again, let's say maybe this is like a big water tower, and we're trying to figure out how much water can be held in it. Well, what we have a cylinder. The height is 10. You can see that 10 meters. The radius is 4. So I say volume equals pi r squared H. And I'm going to put the numbers in. Leave the pi. Radius is 4. Squared. Height is 10. So what you have is 4 times 4 is 16, times 10 would be 160. So what we get is 160 pi. That would be the exact answer. Maybe we want it as a decimal. Let's see what it comes out to on the calculator. Uh, 160 pi, about 502.6. Now, again, those are both the answer. 160 pi is the exact answer. 502.6 is the approximation. But since this is volume and we're measuring in meters, either one would be measured in cubic meters. So we can use either of these answers. But the units should definitely be cubic meters. Okay, now a cone is just like a cylinder, but we're going to do the same thing we did with the pyramid yesterday. We're just going to say, instead of having a circle on top and bottom, we're going to take one of those circles, we're going to turn it into a point, and we're going to meet at a point on one end instead of having two bases. Now, because of that, you get an extra measurement in there. A cylinder only has two measurements. You have the radius of the circle, and you have the height of the cylinder, and that's it. Well, when you have a cone, you have the radius, because you still have that circle on one of the bases. You have the height, h, but then you also have what we call the slant height, which is the diagonal going down the cone from the point to the edge of the circle. We call it S in this picture. Sometimes I've seen it called L before. S or L for slant height. And basically, what's nice about this, we're going to do the same thing we did for pyramids. We're going to say, if you know how to find the volume of a cylinder, a cone is always exactly 1/3 of a cylinder. So what you can do is you can use the same formula we have for cones and just put a 1/3 in front of it. I'm sorry, it's the same for cylinder and put a 1/3 in front of it. So volume of a cone is 1/3 times the formula for volume of a cylinder, which was pi r squared H. So let's find the volume of this cone right here. And again, turn it into a word problem. Maybe this is a giant cone-shaped, whatever, pile of sand, and you're trying to figure out how much sand makes up the pile, or something like that. So what we have, we can find the volume by doing pi r squared h, just like a cylinder, but then I'll do it in red again like I did yesterday. Just put that 1/3 in front of it, or divide it by 3. Now, the other thing about this is we're missing one piece. When I try to do this, we have 1/3 pi, the radius is 5, that's given in the question, but see, we don't know what h is. What I gave you in the problem is the slant height. That 13 is not the height, it's the slant height. The height is right here. I'm going to call it x. We don't know what it is yet. So we need to find the height first. And to find the height, what I'm going to do, kind of like what we did 2 days ago in our notes, I'm going to use Pythagorean theorem. I look at that. I don't look at the cone, but look at the shape in the middle of the cone. I see a right triangle. I see a right angle down there at the bottom. I see a 5. I see a 13. I got my x. So let's do this. I'm going to kind of separate the second problem down here. Let's do a squared plus b squared equals c squared. Pythagorean theorem. The 13 is the hypotenuse because it's opposite from the right triangle. So I'm going to put the 13 here. The 5 and the x can go either spot for a and b. I'm going to call it x squared plus 5 squared. We do the squaring. 5 squared is 25. 13 times 13 is 169. We subtract 25 from each side. And x squared equals 144. Now we square root to cancel out the square. And this one actually worked out perfectly. We don't even need a decimal. It's just 12. So the height of this cone was not 13. It was 12. Once I realize that, I'm going to put that 12 here, and then the rest of the question is easy. I mean, the rest of the question was the calculator part. So what we do is, again, let's see, a third times 12 is 4. 4 times 12, you get 100 pi. So the volume ends up being 100 pi, or that would be, about 314. And that would be in cubic meters again. So it's either 100 pi or about 314 cubic meters. So that's cone and cylinder. They're very closely related. Think of it, just follow the pattern we did yesterday. Prism, pyramid is 1/3 of a prism. Cylinder, cone is 1/3 of a cylinder. Now there is one last shape I want to show you. It's different from these first 4. But a sphere is basically a ball. It's a 3-dimensional circle. It's round everywhere. It has no flat sides anywhere. Just like a ball. Baseball, basketball, any kind of ball. Now, a sphere actually only has one component. There's no height to a sphere. There's no length or width. There's a radius only. And I know it's very small in the picture, but that right there is r for the radius. So with just that one number, there's only one number for a sphere. If you know the radius of the sphere, you can tell me the volume. The volume is 4/3 pi times r cubed, not r squared, r cubed. So this one has a radius to the 3rd power. So the volume of a sphere is 4/3 pi r cubed. It's a new formula. It's different from the other 4. And let's do one last example. So what I said for our last example, we want to find the volume of a sphere if the radius is, and instead of giving you a number for the radius, I gave you an expression. The radius is 2x plus 7. So let's do that. So volume of a sphere is 4/3 pi r to the 3rd power, or r cubed. So what I want to do is I want to take this expression and put it in there for r. So what I'm going to have is volume equals 4/3 pi times, and then put it in parentheses, 2x minus 7 to the 3rd power. Now that's actually the answer to the first thing I asked you. If I said what is the volume of a sphere with a radius of 2x plus 7, your answer is not a number, your answer is a formula. Now for the second part, I said now find the actual volume when x equals 5. So now you're going to plug that in for x, and you're going to see what the volume actually equals. So let's do that next. Let's do volume equals 4/3 pi times 2 times 5 minus 7 to the third power. Plus 7. You know what? Those are both pluses. Let's fix that. Those are both supposed to be 2x plus 7. So let's clean it up. We have 4/3 pi times, and then 2 times 5 is 10, plus 7 would be 17 to the third power. And at this point, I'm going to have to reach for a calculator. I don't know what 17 to the third power is. So let's multiply this all out together. We get, try that again. We get about 20,579, and that would be in cubic units. I didn't give you units for this one. So if I don't give you units in the question, you don't have to give me units in the answer. But we got a very, very big number in there because our radius was big. Our radius was 17. And when you raise something to the third power, it's 17 times 17 times 17. That turns into a really big number. So our volume ended up being over 20,000 cubic units. It was a very big sphere. But you get the idea. The formula for a sphere is pretty simple. There's only one number, the radius. If you know what it is, just plug it in and you got it. Even if it's an expression. Like this example, I tried to make it a little bit harder. I mean, I could have just said, okay, the radius is 10, find the volume, and you basically just grab a calculator and type numbers. But if I say the radius is 2x plus 7, just put that in for r. Then maybe later, like this one, I ask you, okay, now what happens when x equals 5?